Thank you. So hello, everyone. I will present you the current state of our implementation of regarding the expiration of indicator in the MISP platform. So I will quickly go over the different components used to actually decay indicators in MISP, and also present you how you can extend the model to support your own algorithms or different formulas. So yeah, and also I will try to do a demo. Hope it will go fine. So just to come back to the previous talk we had this morning by Mr. Rocco Di Domenico, which presented a content-based recommendation system for indicator components lifecycle. The approach that we use here is quite different, as we only consider the attributes and its context itself. So without doing queries against different feed or different providers. So that's how we implemented the formula and the algorithm to actually decay. But in addition to this, you also provide a design and an architecture to support also your own things. So for the talk you did this morning, you could actually implement it directly in few lines of PHP, I guess, well, few lines. Just a query against your tool that you have and then return back the data. But I will show quickly how you can do it easily. So why and how we expire IOCs. So I guess if you are older, you already know that sharing information about threat is critical, and also that organizations are sharing more and more. So if you look at this small table, it's just numbers of unique organizations that contributed in our production instance. You can see that it's growing over time. And also, if you look at the attendees, the number of attendees we have today, it has quite increased over the years, proving that more people are using this, but also more people are sharing. So to set the few problems that you have, so if you are using MISP, you will have information coming from various users and parties, where you will have to deal with the data quality, certainly, the trust that you put in the data you received, and also time to limp issues. But also, depending on your use case, you will have different interests in the data. So if you are doing operational security, like blocking IOCs, blocking things, you only want actionable data or true IOCs. While if you are doing some researches, for example, you are interested in everything, even false positives. And this is, in our model, more or less solved with the help of taxonomies. And also, as we are sharing a lot of data, there are a lot of data in our MISP. So, for example, that's a number that we have in our production instance. But you also have partial information about the freshness of the data itself, thanks to the sightings. We already had a talk this morning about the sightings, and it's great so that I don't have to do a refresher. And also about the validity of the data. So the last time the attribute was updated. And this, together with the taxonomies and the sightings, form our decaying models. So how to enjoy this new feature in MISP? So it's fairly new. It's 1 month old. So you have to be at the version 2.4.116. You have to update the decay models. I will quickly show during the demo how you can do it, and enable the one you want. Then, of course, this scoring and models and decaying score are computed on the fly. So they are not stored on this. They are not altering the data. So it's just an overlay, in fact, via the user interface or via the API. And also, as our model strongly relies on taxonomies and sightings, you have just to review their settings. So be sure that you have the up-to-date taxonomies, and then you actually sharing sightings, and you don't have strong policy on your sightings. So quick refresher. We have it, we had one this morning. So just sightings are used here to prioritize based on the freshness of the information. So if you have sightings on attributes, it may mean that this has more interest than one that doesn't have any sightings. So that's basically how we are doing it. So we have 3 types of sighting in MISP. We have sightings, the standard one, the false positive one, and the expiration one. As of today, for the current implementation, we only support one, the sightings one. But later on, for the next version, we'll support also false positive and the expiration one. But that's just a side note. So quick refresher for the taxonomies. So there are simple way to attach classification to any event or attributes. And also the classification must be used globally to be efficient. So you have to agree with your partner or everyone using the same MISP to use the same one, because if everyone is using a different one, it's quite hard to have a good view on the data to actually decay it using our models, because you have to specify which taxonomy you want to be taken into account while computing the score. But we'll go over it in the next slides. So again, this is another taxonomy. It's the Admiralty Scale taxonomy. You can notice two things. You can cherry pick the tags that you want to have in your system. So you're not forced to use every entries in the taxonomy in your system, but you may probably know it. So for example, this one, the last one, is not used in the system. And the second one is you maybe didn't notice at first when using it, but we have a column in the taxonomy called numerical values, which contain a numerical value of the taxonomy. So not every taxonomy have a numerical values, but for tools that have this numerical value, this is used to actually use the taxonomy to compute the score. So these are just two examples of the Admiralty Scale taxonomy, a few examples of numerical values. Right now, these are fixed in the taxonomy itself. You cannot edit it unless you edit your taxonomy files. But in the next version, users will be able to override on the fly this numerical value, because sometimes you may not agree with the numerical value associated to it. So basically, the numerical value is just a way to attach a numerical value to a concept. So in that case, usually a reliable would have a numerical value of 75. So it's just a way so that we can use this information into a formula so that we can have a numerical value in the end. So this is the solution we have currently in MISP. So we are computing, I'll take the pointer. Okay, cool. So we have the score here. So we are computing a score of the attribute. And to compute the score, we are using two components. The first one is the base score, which is the initial score, I would say. So it's based on the attribute and its context. So the attribute value, the type, the different taxonomies and galaxies are attached to it. And when you have this base score, you will decay it, so decrease the value of this base score over time with the time and of course some models parameters. So the decay here shown here is just a function defined by the models parameter that you set, and yeah, the model contains the model configuration, but you will see that in the demo. So the base score is in fact the initial score of the attribute without considering the decay or the expiration over time. And this is the place where part of the ideas from the talk that we saw this morning could be integrated, where you consider the different sources and the existence of the data in the different feed. That this is where in the base score that it could be plugged, so that based on the existence of this information in the feed, you would adapt, increase or decrease the base score based on this information. And yeah, the second one, the decay. So the function that is reducing the score over time is just composed of two parameters. The first one is the lifetime, which depends on the attribute type that you set, but basically it's a way to express how long an attribute should be kept, or an IOC should be kept in the system. So you would say, I want it to be up for 3 days. I want it to be up for 1 year. And the second parameter is the decay speed. So at what speed the attribute will lose score over time. So current implementation in MISP. So this is the classical event view. And what you can see is we added a new button. It's called the decay score. And if you press on it, you will have a new column score that will appear. And that contains the model itself that you have defined in your system, along with the score that this model computed. So in some, it's green, meaning that the attribute has not decayed, but for some, it's all red, meaning that it has decayed. So when you do an API request and you want to enforce the filtering based on the D score, this one will be filtered out. So this is a sample of an API request that you could have. So if you do a request on the attribute res search one, you will have a new field called decay score, which contains the score, the actual score computed at the time of the request. If this attribute is marked as decay or not, so that you can filter it out or do more queries against it. And a small information about the model used. You can also request more information, but this is just a sample. So we are still under development, so it's working. I guess it's production ready. But for that, we need your feedback. But so these are the objectives that we've set ourselves. So when we implemented the decaying in MISP, but we also want to keep it when we do the version 2 and 3. So basically, an automatic way to score attributes based on the different model and a user-friendly, user-friendly interface to actually set and configure the different models so that you have a visual feedback on what will be the impact of adjusting this parameter. A simulation tool so that you can see, well, how it goes over time. Interaction through the API, you've seen it. And last one, but not least, the opportunity to create your own formula and algorithm if you do not agree with our base score and decay system. So just last slide, theoretical slide regarding the different definition that we have. So a model, it's called like this in MISP, is in fact an instantiation of the formula. So this formula where different elements can be defined. So different parameters like the lifetime with how long the attribute should be kept in the system, the decay rate, so at what speed it will lose score over time, an optional threshold that you can set to prematurely expire an attribute, how the base score should be computed. So based on your different configuration in the taxonomy. So you could say, I want this taxonomy to be more important than the others when I'm computing the base score. So that's the thing you could do. Default base score to have a fallback value if you don't have any taxonomies or tag attached to an attribute. The formula itself to use. So by default, it's this one. Associate the model with the attribute type, because if you want to expire a dynamic IP address, you will probably want to have a small lifetime, so few days, while if you want to expire a file hash, it may be more long, so few months perhaps, depending on your use case. But this is how, so you can set the mapping between these attribute type to the models. And last one, creator organization, so that you can use the model created by your organization and you can share it with others, and so on. So you have two types of model inside MISP. You have a default model, which is coming from a repository similar to the galaxies and taxonomy that we have. So you just have to update it so that you can quickly get all the information and all the model that we've defined immediately in the system without playing around. So it's kind of built in MISP. And the second one is the organization model. So that's the one you create and you adjust to your use cases. So the first one is not editable, only by editing the JSON itself or just by doing a pull request on the MISP decay model repository. And the last one is editable, of course, because that's your own model. So this is just a decaying event for an example that I've created. So you can see that we have a few attributes with some tags. And if I click on the decay score, we have, maybe I should zoom or. And so you can see that we have a column score and the different value for the different model. So if you click on one, so let's say this one, if you click on it, you will arrive in a simulation page. Well, it's not correctly under due to the zoom, but I guess it's more or less visible. Maybe I should unzoom a bit. Okay. And so in this interface, you can see the simulation and how the attribute decayed over time and when it will be actually marked as decay. So we are currently in that state and it will be marked as decay in this position. And we can see the 2 spikes here comes from sightings that this attribute received over time. So you can see the 2 sightings here are just reflected by this graph. So we can see that upon a receive of a sightings, it will lose score, and then upon a sighting arrives, it will refresh the score to the base score, and so on. You also have a few information about how the base score for this specific attribute were actually computed. Okay, this one, yes. So it also includes this simulation page also include a REST search support so that you can do quick searches and play and check for the different results of the different models. So this is what the index of the decay model looks like. You can update them. So from the repository MISP decaying model repository, you will load all the models into your MISP instance. You can check for your models, the share model, the default one, the parameter used in the model, if it is enabled or not, so that you can easily enable the model or not, import it, share the models, and so on. So the default model shipped by default are coming from this repository. So if you want to share your model with us or with the community, don't hesitate to do a pull request on this repository. So I was talking briefly about a nice interface to modify visually and to have a feedback on the influence of the different parameters in your model. So in this interface, it's a way to easily create the models without just typing in a JSON file. So first you have to define which formula to use. So in that case, it's the polynomial, it's the standard one that we implemented. And then you can play with the different sliders. So if you want to increase the lifetime, you can do it like this. If you want to play with the decay speed, you can either play with this button or just drag this point so that you have a kind of intuition on how it will be decayed over time. Then you can also play with the threshold and so on. For the base score computation and how important you would put in the different taxonomy, you also have an interface where you could set the base score and play a bit with the different taxonomy and how they will be used to compute the base score. Then you have few examples that shows how it would be computed with these different tags so that you have a better understanding on how it works. Okay, so last example. So I've presented the polynomial function to compute, but we have another one called polynomial extended. It's similar to the polynomial one with the standard decay one, but it also supports this reduction taxonomy. So it's a taxonomy that is defined in MISP since, I don't remember since when, but it's a few months, I guess. It's a way to explicitly say, I want this attribute to be marked as decay after X amount of time. So it includes tags like 1 day, 1 month, 1 year, 2 days, and so on. And what the extended polynomial formula do is just compute the base score normally. And if there is a retention taxonomy tag attached to it, it will just override the behavior. So if we look at this one, it's similar to this one that we have here. But this one have a retention of 2 days, and it will be just marked as decay because the tag take precedence over the actual score computation. And so for the REST API, if you're familiar with the REST client, you can play a bit with it. But you have, once again, here the score attached to the attribute itself when you are doing a query. So these are just backup slides in case if anything goes wrong. So to quickly cover what you can do with it, you can ask to include the decay score. So just to attach the score computation into the attribute. Yes, you can include the full model if you want to have a whole view of the model that computed it. You can, if you specify exclude decay to true, it will just filter out every attribute that has been marked as decay. so that you don't have to do it yourself. You can specify the different decaying models, and you can also adapt the different parameters defined in the model on the fly. So for example, if you would want to put a higher threshold on the score, you could do it quite easily by just overriding the parameter. And so the architecture that we've developed to support different algorithm and formula, it's quite easy. So it's just a file that you have to copy paste. And then you just have to extend decaying model base class, and then you have two functions to implement basically. So the first one is compute base score, which should return a score, a numerical score. And the second one is decayed. So in that case, it returns a Boolean if the attribute should be marked as decayed or not. And so basically, if we have a look at what you presented this morning, you could, for example, put all your code in that place, and then based on the result of this one, just return if it is decayed or not. So that's a way to quickly filter things out. So what we are planning in the second version of the decaying model is to improve the support of sightings. So we only support the standard sightings one, but we also want to import false positive that would decrease the score even more. Also the expiration sighting, which would take precedence over what we already read, so similar to the retention taxonomy. Some potential model improvements. So instead of just resetting the score to the base score when an attribute receives sightings, do it differently. So like an additive thing where in the end, we would prioritize surges rather than just infrequent sightings. So if you just have a sightings on attribute that is 2 years old, it would have a smaller impact than just a lot of sightings on these attributes. And also increase the taxonomy coverage. So I hope I was not too fast because the time frame was really short to present this complicated feature that we have implemented. So if you have any feedback right now or later on, we can have a chat. We can have a chat also together later on if you want to speak a bit more about it. So do you have any question? Yes, you have one.
Will it be possible, is it possible now or in the future, will it be possible to add a publishing organization as a variable in the decay formula? So if I'm getting something from cert foo, I want to retain it longer than something from cert bar.
Yeah, so that's something that I didn't talk about, but because in our original paper where we describe our decaying models, we also consider the trust that you have in a specific organization. But as this is quite tricky to be used because it's not really, you cannot compute it like this. You have to assess the trust that you have in the organization, but also how they may change the data if it's quite hard to explain like this. But basically, we didn't integrate the trust in this. We wanted to do it in the future where you can just specify, okay, these 3 organizations, I trust them, no influence on the base score, but these 2, I do not trust them really much. And so it will just decrease the base score. So that's how we wanted to do it in the end. But yeah, there are also some game theory involved in this trust and yeah, so it has a lot of influence in the base score computation, but yeah. Any other question? Yes.
Thank you. Really exciting. One of the practical questions you mentioned the taxonomies with the numerical values, for example. I'm wondering right now, can you what would be the impact of an absence of such a tag? Is there like a base value you can set when that tag is not present? As with like, for example, the reliability or certainty or something like that, you can say like, I consider it like average when the tag is not there, but when the tag is there, I have this extra info that can help me. So that's a first question, or you've thought about it already, and it's implemented yesterday.
Yes, that's a good point. So right now, that's why we have the base score. If there is an absence of any taxonomies or tags attached to it, or thing that you don't have defined or tied with your models, it will fall back to the default base score. But for tags that are missing from taxonomy, so if you have a taxonomy and you're expecting that this attribute should have a tag, but it doesn't, we don't have a fallback value for this. So we just ignore it, and it's not taken into account in the base score computation. But yeah, having a fallback value is not actually a bad idea, especially if you are forced to put some tags for publishing and they are not defined. Yeah, that makes sense.
Thank you. And the second question, you mentioned that you will be working on a simulation tool, which is really good because the challenge lies into finding a good balance between all those different levels of expiration. Now, I'm wondering, how do you see the outputs of such a simulation tool in how can such a simulation tool give an output that can help us assess the consequences of our choices? Does that make sense? Or
Yeah, so indeed it makes sense, but we didn't thought about that. I mean, if you have any ideas about it, we would be glad to hear, because, I mean, the simulation tool is just a way for you to see how it will behave over time, but don't really gives you hints on how you should fine tune your models. That's right. But yeah, if you have any ideas on how you could extract this kind of data to better fine tune your models, aside from doing statistical analysis on your data.
Just throwing some ideas, looking at maybe so the delta, really the previous run and the new run, and see what's the effects of the change. That's one key element, or potential elements to keep in mind. Another would be, what kind of, marking, so tags, galaxies or so, do I lose? Which one do appear after my change? So that can help me, for example, if I know APT2, I'm just throwing a name, is important for me, and I notice that after my tuning, I have more APT2 coming out, so that's great. But if I notice I have less, that means that my tuning is not optimal because I'm very much worried about APT2, and I want to be sure I see it even if it's 5 years old. Does that make sense? Yeah. Or these type of, so really see the effect, but it's showing the attributes themselves is probably unmanageable because of the volume or the amount of data coming out. So it would be like trying to find ways to show a human understandable summary of those changes.
Yeah, so a simulation, but not for one specific attribute, but for the whole set of the data. Yes, that makes a lot of sense. Yes. Yeah, that's a good point. Thanks. Any other questions? Okay, thanks. If you have any other question later on or want to learn more on how you can use it, just don't hesitate to ask me. Thank you.